In this video, we introduce FastCA, a new solver for constrained covering area generation. This problem is a core task of combinatorial interaction test, which is a widely used technique for detecting interaction faults. FastCA not only has an impressive ability to generate smaller covering areas, but also achieves a great reduction in time cost, which makes it adaptive to most practical situations. Now we'll introduce the usage and functions of it. First, we pull the source code from GitHub and compile it with the make command. Information about the system under test is recorded in the input file. In this file, the system name is given at first. Options and their possible values are given in order, and the constraints are specified after that. More details about the format can be found in README, so we'll skip its description. Then let's run FastCA by the execution command. In this command, the input file, the covering strings, the cutoff time, and the path of output are all specified in order. Here, just for a simple example, we set the cutoff time to 20 seconds. Okay, now after the execution, we see that FastCA generates a covering area of size 147, and more details are output to the results file. In this output, all options and its value range are listed at first, and then the resulted covering area is given by rows. We have conducted more experiments to compare FastCA with other state-of-the-art solvers. For the Apache instance, FastCA generated a covering area of size 141 in 100 seconds. While even given much more time as 1,000 seconds, TCA only got the result of 154, S got 173, CASA got 245, and HHSA even failed to get a solution. So we can see that the superiority of FastCA is really obvious. In addition to the basic generation, FastCA can also extend covering areas from existing test sets, which is recorded in the input file as well. In this file, there are 3 test cases given by the user. Note that it is allowed to list options out of order and to use asterisk for don't care values. In particular, for some invalid test cases, such as the first row in this one which violates the 5th constraint, it will be filtered by FastCA and not appear in the output file. The command for extending is just as same as the original one, except that the test sets need to be added into the input file. Then let's run it and have a look about its output. It can be seen that the first given test case which is invalid is filtered out, and the other 2 are still reserved, corresponding to the first and the second rows in the resulted covering area. We also want to introduce the parallelization of FastCA. Users can set the number of threads in its execution command like this. Here we take 4 threads as an example, and the cutoff time is also set to 20 seconds. Then let's run FastCA by the execution command. It seems that with 4 threads, FastCA searches about 9,000 steps in 20 seconds. While with a single thread, the value is only about 4,800. Actually, FastCA can achieve further improvement on its efficiency if the parameter is set appropriately.